All right, what we want to do now is get some practice using these in real-world problems because these are very common scenarios that arise where you can use substitution or elimination to solve some sort of word problem. They especially like to put these a lot on the SAT or the ACT math section. Okay, so we can use either method, but I'll show you this one. This one's a little bit easier. The next one will be slightly more challenging. So if you think you know how to set it up, go ahead and try it, and then hit play when you're ready to look at the answer. This says the school that Mike is going to sells tickets for the annual talent show. On the first day of ticket sales, the school sold 2 senior tickets. So I'm just going to underline the things that look like they're going to be important in our equation because there's a lot of words here, and part of this challenge is we're going to have to translate the words into math. So 2 senior tickets and 6 child tickets for that amount of money, $66. Okay, on the second day, they made $129 by selling 7 senior tickets and 4 child tickets. Find the price of a senior ticket and the price of a child ticket. So the first thing you should do in these word problems is you should identify your variables. Okay, identify the variables and what they mean. Okay, so let's do that. So what are the variables? Well, variables stand for things that we don't know. And what we don't know in this problem is we don't know the price of a senior ticket. So I'm going to call that S. S is the price of a senior ticket. And we also don't know the price of a child ticket. Okay, so I'll use a different color for that. We don't know the price of a child ticket, so we'll let C for child. C will stand for the price of a children's ticket. Okay, so that's our first step, is to identify the variables. Second step is to write an equation. Okay, we want to write an equation, or actually, I'm sorry, write 2 equations with these variables in them. So let's write our 2 equations. The first equation is going to involve that $66. So let's think about it. $66 is the amount of money they made on senior tickets plus child tickets. So we don't know how much money they made on a senior ticket. We do know that they sold 2 of them though. So hopefully this will make sense to you. If a senior ticket cost $10 each, then if you sold 2 of them, you'd make 20. 2 times 10. If a senior ticket costs $100 each, if you sold 2 of them, you would make $200. 2 times 100. So if a senior ticket costs S dollars, that means if you sell 2 of them, you would make 2 times S amount of money. So hopefully that makes sense. If not, give it some thought. Okay. Same idea. If we sell 6 child tickets, if we sold $1 for each ticket, it would be 6 times 1, or $6. If we sold 6 tickets at $2 each, it would be 6 times 2, $12. If we sold 6 tickets at $3 each, 6 times 3, we're selling them at C dollars each, so it's going to be 6 times C. That's the amount of money we make off children's tickets. Okay, same idea. On the second day, we make $129 selling 7 senior tickets. So we made 7 tickets times S dollars a ticket, 7S. And then we sold 4 children's tickets, so 4 times the price of a child ticket. Okay, now we're in a position to be able to solve this using either substitution or elimination. It doesn't really matter. Let's just take a look what might be easier here. Usually elimination is easier, so let's just go with that. Okay, so let's eliminate the C's. It doesn't matter. You can pick which one you want to eliminate. The reason I chose C is because I see 6 and 4, and I know that those have a common denominator of 12, so I can easily change those into 12. So let's change the 6C into 12 by multiplying by 2. 2 times 66 is 132. 2 times 2s is 4s. 2 times 6c is 12c. Down here, how do I change this into 12? I would multiply by 3. 3 times 129 is, I believe, 387. I think, is that right? Yep, 387. 3 times 7s is 21s, and 3 times 4c is 12c. Now the question is, how do we eliminate the c's? By adding or subtracting. If I added 12 and 12, I would not eliminate them. I'd have 24. So I need to subtract. And whatever I do over here, I have to do everywhere. So 132 minus 387 is going to be negative 255. 4 minus 21 is negative 17. And 12 minus 12, that's just equal to 0. So that goes away. Now we need to divide both sides by negative 17. By the way, because we're talking about the price of a ticket, notice that it wouldn't make sense to get a negative answer. You can't charge negative money for a ticket. So we have a negative divided by a negative. That's okay. That's going to give us a positive. So 255 divided by 17, I believe that's 15. I don't have a calculator, but yeah, I'm pretty sure that's $15. So that's how much money a senior ticket costs. And now let's solve for the price of a children's ticket. Okay, the price of a children's ticket, we can just sub it in right here. So 66 equals 2 times S. That means 2 times 15. 2 times 15 is 30, so we'll subtract 30 from both sides. And we get 36 equals 6C. So that means if we divide by 6, C is equal to $6. So $6 for a children's ticket and $15 for a senior ticket. And we could always check that by plugging it back into the original and just verifying. So 2 times $15 is 30, 6 times $6 is 36, and that does equal 66, and the same for the other. Okay, the next one's a harder problem, so I want you to give this a try. It's definitely a challenge, but challenge yourself, and if you, when you're ready, hit play, and on the next video, we'll do it in the next video, and then we'll see what the answer is.